Okay, we're going to conclude our discussion on derivatives now by talking about what's called the chain rule. Okay. Well, on these, if I wanted to find the derivative of this, I could multiply it out. Okay. I'm hesitant to say easily multiply it out because this is not something that's necessarily easy to do. Okay, it's time-consuming to multiply it out. But thankfully, there is a nice way, a nice rule that we can use to find the derivative of this without actually having to go through all the algebra of multiplying it out. And what is that rule called, you ask? Well, it is called the chain rule. Okay? We have the chain rule. So, why do we call it the chain rule? Well, what it says is, okay, that if you have a function within a function, okay, this is called the composition of functions. Okay, you have a function, this x squared plus 3x, okay, that's all being taken to the third power. So, what it's saying is, we work with the outer terms first, okay, so we have f of x equals g of x of f of g of x, is what I should say, f of g of x, okay, we find the derivative of the outer term, okay, so f prime of g of x times the derivative of the inner term, which is g of x. Okay? So, what we have here, this is like saying something to the third power, okay? So, something to the third power. So, 3 to the power of, alright, so 3 times x squared plus 3x, okay? So, x squared plus 3x, that's our something. Okay, and then we're going to take the derivative of that. So, we brought the 3 out front, we have to subtract 1 from it, make it a 2, okay? And then we have to take the derivative of what's inside. So we take the f prime g of x, that's what we did here, and then we have to multiply it by x squared plus 3x, or the derivative of that. So the derivative of x squared plus 3x is going to be, would be 2x plus 3. And so that would be the derivative. We could stop there, but often we like to reorder terms, make it a little bit nicer looking. So we would have 3 times 2x plus 3 times x squared plus 3x quantity squared. And that would be the derivative of this by using the chain rule.